Welcome back to the deep dive. If you thought the AI hardware race was, maybe slowing down as we closed out 2025, think again.
Not even a little bit. What we just saw is a foundational shift.
Yep, we are starting the new year by unpacking what I can only describe as a seismic event, this huge strategic deal between Nvidia and Groq.
And for anyone tracking the space, this computational arms race, this is the signal. The battleground has officially moved.
So let's get straight to the facts. On December 24th, Nvidia, already the most valuable company on the planet, announced a strategic pact with Groq.
The inference chip specialist.
Right. And while Nvidia's stock barely blinked, it went up maybe 1.5%. The deal itself was huge.
Right.
We're talking a reported $20 billion for Groq assets and, crucially, its core team.
And this wasn't a standard acquisition, which is what makes this so fascinating to unpack.
How so?
Well, it was strategically structured. They're calling it a non-exclusive technology licensing pact. But the real story is that paired with that license was a massive acqui-hire.
Ah, the acqui-hire.
Exactly. Groq's founder and CEO, Jonathan Ross, and you have to remember, this is the guy who was the primary architect of Google's original TPU. He's now joining Nvidia.
Along with President Sunny Madra and other key people.
The whole core team. They're all going over to Nvidia to advance this licensed technology.
Okay, let's frame our mission for today then. It's really all about the future. Why would Nvidia, the reigning GPU champion, spend $20 billion, their largest acquisition ever, to absorb the talent and tech of its most distinct rival?
And what does it tell us about where AI is going? Because that's the real story here.
Right. We're clearly moving past the training era where you're just building these massive models and squarely into the critical latency-obsessed inference era.
This is where the models have to actually live and breathe and respond in real time. This is market consolidation, but it's disguised as a technology partnership.
It seems to signal that the core innovation that they needed for this next generation of AI, this real-time thinking, was actually outside of their own walls.
And they paid a massive premium to bring it inside.
Speaking of that premium, $20 billion. That number is just staggering, especially when you consider that Groq had, just months earlier, raised money at a $6.9 billion valuation.
It was a lightning-fast, aggressive strike, and that speed, that structure...
Yeah.
It's all part of the same motivation.
So by licensing the IP and then just grabbing the talent, the acqui-hire part.
They secure the tech, they neutralize their most potent rival, and they do it without triggering the traditional, very lengthy antitrust scrutiny from, say, the Hart-Scott-Rodino Act.
So they bought the brains, but not the whole company.
There.
Are the critics right? Is this just a tactic to skirt those regulations while preserving what some are calling the fiction of competition?
That is precisely the claim. They get the technological edge and the genius behind it, but they avoid all the bureaucratic baggage.
And the genius they got is immense. Jonathan Ross is the real prize here, isn't he?
He's the ultimate prize. He pioneered the TPU at Google. His entire philosophy is built around software-defined hardware.
Which is fundamentally different from Nvidia. Their entire empire is built on hardware first, with the CUDA ecosystem sort of dictating everything.
It's the intellectual opposite. For decades, NVIDIA hardware has been all about maximizing parallel throughput. That's great for training, great for huge batches of data.
But Ross's design, the LPU,
it focuses almost obsessively on sequential processing, on minimum latency. The hope, and the $20 billion gamble, is that merging these two philosophies creates a kind of unified compute fabric.
You get NVIDIA's scale with Groq's speed.
That's the idea.
I have to ask, though, the deal happens, the core team walks over to NVIDIA. But what's left of Groq? The company still exists, right? Now it's led by the former CF, Simon Edwards.
The remaining Groq entity has to find its way forward without its key architects. NVIDIA didn't just absorb the tech, they absorbed the people who could actually advance it. It just underscores how aggressive this was.
It was about eliminating the architectural rivalry before it could really scale. That makes sense.
Yeah.
Okay, we've talked about the deal structure, the money, but let's be honest, $20 billion is only justified if the technology is truly revolutionary. So let's dive into that LPU architecture. What made NVIDIA panic?
This is where it gets really interesting. The urgency comes from where AI is headed. We're moving toward these complex System 2 reasoning models.
Things like OpenAI O3 or DeepSeek R1.
Right, and they rely heavily on what's called chain of thought or CoTT prompting.
Okay, hold on. What does chain of thought actually look like in practice? Give us a real-world example.
Okay, think about a sophisticated AI diagnostic tool or a real-time coding agent. You ask it a complex question and it doesn't just spit out an answer.
It has to think.
It has to think. It performs these repeated internal reasoning steps. It might outline the problem, generate a few potential solutions, critique those solutions, and then synthesize a final answer. Each of those steps is sequential, one after the other.
And if each of those sequential steps has just a little bit of a delay on traditional hardware,
you get a latency catastrophe, a few internal steps, each with a slight variable delay. And suddenly, the final response time stretches into minutes. An interactive agent becomes completely unusable.
so the LPU architecture is designed specifically for that thinking workload.
It's uniquely suited for it because it eliminates that variability.
All right, let's look under the hood. The LPU is built on a tensor-streaming processor, a TSP. And the key feature is static scheduling. Why is that so different?
Well, think of it this way. A traditional GPU uses dynamic scheduling. That's like driving in rush hour traffic. You've got stoplights, you've got branch predictors guessing where to go. It's just inherently non-deterministic. Your commute time is always different.
I know that feeling.
We all do. Groq's LPU, with its static scheduling, is like a perfectly synchronized subway train. The compiler, the train scheduler, orchestrates every single instruction of every data movement down to the exact clock cycle before the code even runs.
So there are no guesses, no dynamic management.
None. No branch predictors, no synchronization locks. It guarantees a deterministic, lightning-fast response time every single time. That's its superpower for latency.
Okay, that explains the timing. But the sources all point to another problem the LPU solves, the memory wall.
The memory wall is arguably the biggest bottleneck in AI inference today. Top-tier GPUs, including Nvidia's, rely on massive amounts of high-bandwidth memory, HBM, which is physically off-chip.
And so data has to travel back and forth.
And that creates latency. The LPU just sidesteps that whole problem.
How?
It demolishes it. The LPU integrates 230 megabytes of ultra-fast SRAM, and this is the key, on-chip.
So the memory is right there on the processor.
Correctly on the die. And it provides an astounding 80 terabytes per second of bandwidth.
Wait, 80? As in 80. That's nearly 10 times faster than the HBM3E in top GPUs.
It's a massive number, and what that speed means is the LPU can keep the entire working model, like an 8 billion parameter model resident, right on the chip. There's no off-chip travel. The memory wall is just gone for those tasks.
Which is what leads to those stunning performance numbers.
Absolutely. The benchmarks are just jaw-dropping.
Running the Llama 3 8B model, the LPU delivers over 800 tokens per second. The comparison is, what, about 150 on a GPU cloud instance?
Roughly, yes. And here's the crucial connection. The LPU maintains that high performance even at a batch size of 1.
And why is batch size of 1 so important? I thought bigger batches were more efficient.
They are, for training. But think about a real-time AI agent, a chatbot, a voice assistant. There's only one user waiting for one answer right now. You can't wait to pile up 32 other queries to make a big, efficient batch.
Batch size 1 is the definition of low latency.
It's the only thing that matters for that user experience, and the LPU wins that game hands down. And it does it while being incredibly energy efficient. We're talking way fewer joules per token.
So this move positions Nvidia to lead in green AI as well. This isn't just a faster chip. It's about owning that entire real-time, instantaneous AI experience. So let's pivot to the broader strategy here. Analysts are projecting the inference market, the actual use of AI, will be over half of all AI compute demand by the end of 2026.
So this deal is Nvidia building a massive defensible moat around that future market.
And it instantly puts the pressure on everyone else.
Oh, absolutely. Consider AMD. Their Instinct MI355X chips were making gains, competing on offering more HBM capacity, more memory bandwidth.
But
now they face a unified Nvidia that's targeting the highest margin, lowest latency applications. The very market where HBM capacity suddenly matters less than the LPU's raw speed.
And what about the hyperscalers? Microsoft's Maya, Amazon's Trainium. They were all about building custom silicon to control their own destiny.
Well, that just got a lot harder. If Nvidia can offer an LPU-derived solution with a lower total cost of ownership for these real-time agents, it makes building your own custom silicon a much riskier bet.
It's the checkmate move. They can now offer the best of both worlds. GPUs for training and this LPU logic for the thinking part.
That's the pitch.
So what does the future Nvidia hardware stack even look like? How quickly can they get this $20 billion investment into a product?
There's a phased roadmap. In the near term, we're expecting a dedicated inference accelerator card. Probably around Q3 2026.
And that would be built directly on the licensed Groq designs.
Yes, targeting that latency-sensitive edge cloud and enterprise market.
And the long-term play, the true integration.
That's the big one. The plan is to integrate LPU logic directly into the successor to Blackwell, the architecture currently known as Vera Rubin.
Treating a hybrid chip.
The expectation is a hybrid GR GPU, a Groq Nvidia GPU that perfectly balances Nvidia's high throughput with Groq's sub-100 millisecond latency.
It all sounds perfect on paper, but the biggest hurdle is almost never the hardware. It's the software.
That is the single biggest technical risk. Groq's compiler is architected for static scheduling. It's fundamentally different from the established dynamic CEDA ecosystem that every AI developer on Earth already uses.
So Jonathan Ross's main job is to fuse those two completely different worlds together. Why is that so hard?
Because the compiler is the brain. A developer needs a single, seamless way to write code that can target both the GPU part for parallel tasks and the LPU part for sequential steps. If they can't create a unified inference architecture,
Then what?
then developers face a nightmare of complexity. They'd have to rewrite code depending on where it's deployed. And in that scenario, they'll just choose what's familiar. The $20 billion advantage gets buried under software problems.
That puts a serious wrinkle in the narrative. But circling back to investors, the short-term view is still overwhelmingly optimistic, right?
Right.
Price target is around $254.
The optimism is warranted because of the technology they just secured.
Yeah.
But we have to look at the long-term risks. And the biggest one is antitrust.
The idea that regulators, especially the DOJ and the European Commission, are looking much more closely at these non-traditional killer acquisitions.
Exactly. Deals designed to eliminate innovative rivals through these strategic licensing and talent grabs. The argument is that Nvidia can just buy out any architectural competition, which raises the barrier to entry for everyone else.
For the industry, then, the Groq deal signals something much bigger.
It signals the definitive end of the GPU-only data center. We're moving into a blended world, an age of heterogeneous AI compute. And in that world, specialized chips for inference, like the LPU, are essential for dominance.
A profound shift indeed.
And that brings us to our final segment. This is not financial advice, but we do like to explore some outrageous but plausible trade ideas based on what we just dissected.
Okay, so the core insight here is that the LPU uses super-fast on-chip SRAM to basically eliminate the memory wall for inference. It makes big off-chip HBM GPUs look suboptimal for these new thinking models.
And Jonathan Ross, the guy who pioneered this SRAM-first approach, is now in charge of NVIDIA's inference strategy. That signals a huge pivot away from relying only on HBM for the competitive edge in this market.
Which leads us to our outrageous but plausible trade idea, short AMD.
Ooh, bold.
The bet is that the LPU's superior SRAM architecture will make high-end HBM GPUs, like AMD's Instinct MI355X, look overpriced and suboptimal for this critical latency-sensitive market, especially by late 2026, right when NVIDIA's new inference accelerator card is set to launch.
So you're betting on the architectural inferiority of a rival's flagship product.
In the face of this new specialized LPU tech, yes.
Now remember the complexity. The success of that short hinges entirely on the risk we just talked about. Can NVIDIA actually integrate Groq's unique compiler into the massive CUD ecosystem?
And can they launch that new card on schedule in Q3 2026? So even with $20 billion, the software integration could still fail.
It is the single most realistic point of failure. If fusing the compilers takes longer, or if it's too complex for developers, then the LPU's hardware advantage gets stuck behind a software bottleneck.
Which buys companies like AMD crucial time to pivot their own roadmaps.
It's a huge risk. But if that integration succeeds, the architectural shift is foundational.
A truly high-stakes gamble built on silicon and source code. Thank you for joining us on this deep dive. Now go forth, think about those subway trains, and continue exploring this rapidly changing AI landscape.